Now we can also look at powers, and how do we take powers of complex numbers written in polar form? Well, let's base it off of how we found the product. So imagine that we have some point written in polar form, and we want to multiply it by another point. And so let's multiply it by so we're having one point times another point. We multiply those through. Remember how we multiply or find the product of two complex numbers in polar form? We multiply the rate of the modulus, so r times r becomes an r squared. Then we add the arguments. So this becomes 2 theta plus I sine 2 theta. And so now we have z squared. Now let's figure out how we want to find z cubed. So let's take this and multiply it by another point. Remember how to multiply products or find the product of 2 points? We multiply the radius or the modulus, so r squared times r becomes r cubed, and then we add the arguments. And there's z cubed. Let's find z to the fourth. How do we do that? Let's multiply z cubed by z to the first. Doing that, you know the pattern. Multiply the modulus, r cubed times r is r to the fourth. Add the arguments, 3 theta plus theta makes it a 4 theta, plus I sine of 4 theta. You starting to see a pattern? I hope so, because that's one of the beautiful things about math is we're able to identify and look at patterns. And so what I notice here is that in each one of these, look where the 2's shine on up. So let's write a generic formula here. So the power formula, z to the n equals modulus to that power of the n times the cosine of that nth root So we're looking for a power of a complex number in polar form. So we have the complex number raised to the nth will equal the modulus raised to the nth and the cosine of the n times the modulus or the argument plus I sine times n times the argument. So let's look at an example then of how we can use that. So based on this formula that we have here, we notice my index, or what I'm raising it to, is to the 6th power. So I can rewrite this then. So this becomes 2. And let's go ahead and clarify it and make sure we can really get it understood. So it's 2 to the 6th times the cosine, there we go, of 6 times 20 degrees plus I sine 6 times 20 degrees. Then from there, we can go ahead and eliminate one of our colors. And 2 to the 6th, what do you think? 64 times cosine of 6 times 1, or 20 is 120. Plus I sine 120. 120, cosine to 120 is an exact value that we know. So that's 64. Cosine of 120 degrees is a minus 1/2. Remember, that sweeps over into the second quadrant. Cosines in the second quadrant are negative. Plus I times the sine of 120, also in the second quadrant. So it's a positive value of a root 3 over a 2. We can go ahead and multiply that 64 through. 64 times a negative 1/2 is a negative 32. Multiply that through plus an I. So we'll do a 32 I root 3. And there's the original complex number in polar form raised to a power of 6. And we can thank a French guy to help come up with that. We can thank Mr. And maybe your French is better than my French, but DeMoivre's came up with this. So anyway, if you got some French background in you, we thank you very much for helping us understand and look how we can develop and solve for powers of complex numbers written in polar form. So let's use our friend DeMoivre's. Again, your French is probably better than mine. DeMoivre's, his model or his theorem on how to take a complex number in polar form and raise it to a power. So let's try to do that with a rectangular form, 1 plus I to the 8th. How would we use his theorem to solve that problem or to work that problem through? Do you notice that I said rectangular form? Yeah, this only works in polar form. So what do? We done? Wrap it up? Lock the doors, go home? No, probably what we can do here is let's convert it to polar form. Why? Because we can. So how do we do that? That means we're coming up with an equation in polar form in terms of r's and thetas. So we need to figure out what the r that matches up with that particular one. And I think you might remember r was the square root of a squared plus b squared, where a represents the real number coefficient and b represents the coefficient to the imaginary number. So that being the case here, that's r equals 1 squared plus 1 squared equals the square root of 2. All right, and now what do we do with theta? Well, theta is the one we need to also remember another one, which was the tangent of theta equals a over b. Now b over a. And so in that particular case, our b is, in this one, they're both 1s. So the tangent of theta equals 1 over 1 or a 1. And what tangent equals a 1? The tangent of pi fourths equals 1. So tangent equals pi fourths. Now, how do I know it's the angle in the first quadrant? Well, I kind of need to have an idea of how that graphs. And so that graphs in the first quadrant over 1, up 1. So then here's my location. Right there's the point, my z. I realize it's in the first quadrant, so it's in the first quadrant. I know the angle that sweeps off of that then has to be pi fourths rather than the one in the third quadrant where the tangent is also equal to 1. So I know, or I now know, or I have confidence that I have my correct tangent. All right, from there we're able to rewrite this in polar form, which is z equals my r. There it is, root 2, times the cosine of theta, which is pi fourths, plus I sine of theta, which is pi fourths. So there's my point that's equivalent to 1 plus I, written in rectangular form to polar form. Now we're going to raise that entire thing to the 8th power. So this is where we can use DeMoivre's theorem, which says then that this becomes z to the root 2 to the 8th cosine. Well, I'll just leave it all in the color. So it's cosine 8 times pi over 4 plus I times sine of 8 times pi over 4. Let's clean that up as best as we can. Root 2 to the 8th power is root 2 times root 2 is a 2. 2 times 2 times 2 times 2 is 16. Cosine of 8 times pi fourths is 2 pi plus I times sine of 2 pi Cosine of 2 pi, one time all the way around the circle. Cosine represents on the unit circle the x-coordinate. The x-coordinate at that particular point on the unit circle is 1. And the sine at a particular point is 0. So my final answer then, or the answer of this written in polar or written back in rectangular form, is 16 plus 0i. Or it can just be written as 16. So what happens when we raise that 1 plus I, that complex number, to the 8th power? We had to convert it over to polar form in order to use DeMoivre's theorem, and then a result becomes a 16.